Yes, dear students, we are going to discuss today the subject that is Medicinal Chemistry 3 theory, and in this we are going to discuss points that is introduction to the drug design and combinatorial chemistry. This is actually a lecture number 2 from the chapter number 5. So we will in the earlier lecture we have discussed about the introduction to the drug design. In that we have covered the points like QSAR, the quantitative structure activity relationship based upon the design of the drug, that is analog base, and the chemical combinations. So related to that we have discussed the factors involved in it, that are quantitative structure activity relationship, some of the physico-chemical properties, and how these physico-chemical properties are going to affect the biological activity. So the physico-chemical properties included are hydrophobicity, how the hydrophobicity constant is going to have the role in the biological activity, followed by we have discussed that hydrophobicity constant, how we are going to calculate the hydrophobicity constant for any hydrophobic group, followed by we have discussed some of the electronic effects and how these electronic effect of the various substituent will going to have the effect on the drug ionization and polarity pattern, and so on. So today we are going to discuss and continuation point of the earlier points. So the point of discussion of today's class are steric factor and how these steric factors will affect the biological activity of any drug. Now, what the steric factor, or what is the role of the steric factor for any drug to interact with the enzyme? Now, various drugs are going to have either effect on the enzymes. Now, these enzymes are there in our body and going to play various metabolic bioinformatics roles in our body. Now, any drug either going to show its pharmacological effect by acting either with the enzyme or with the receptor. So majority of the drugs are going to act either on the enzyme or on the receptor. Now while they are going to act or while they are going to bind to the enzyme or the receptor, they have a special approach. They can bind to the enzymes or to the receptors to the specific binding site. That means the drug structure, the size of the drug or the size of the receptor or the enzyme, and shape of the drug. So this bulkiness, size and shape of the drug will influence how easily it can approach either enzyme or the receptor, because after binding with that enzyme and receptor, they will interact with that receptor or the enzyme and bind to the binding site. Now for that binding, for that approach, the steric properties of the drug, steric properties of that enzyme or the receptors are came into the picture. Now a bulky substituent may act as a shield and hindering the interaction between the drug and the receptor. So the bulky substituent group of any drug and its substructure, if the chemical structure of the drug have the presence of any bulky substituent, now this bulky substituent either going to form a shield or it may hinder the ideal interaction either on the enzyme or on the receptor, and due to this shield or the hindering between the ideal interaction, the drug and the binding site play a very important role, and that role is nothing but the steric factor. Now, bulky substituent may help to orient a drug property for maximum and increase its activity. So due to the presence of this bulky substituent, they may increase the interaction with the enzyme or the receptor and may increase the biological activity of the drug. And similar to this steric factor, a bulky substituent going to quantify a steric properties, which is more difficult than quantifying the hydrophobic and electronic properties. If we are going to quantify the earlier properties, because in earlier class we have discussed the hydrophobic and electronic parameters, but while we are going to compare this hydrophobic and electronic parameters with the steric properties, it is much more difficult to quantify the steric property, and this quantification of the steric properties are done by the Taft's steric factor. We are going to nominate, or we will going to use the short form for the same is ES. Now what is the meaning of the word actually the Taft's steric factor? This highly unlikely that drugs biological activity will be affected by the steric factor alone. Now in earlier class we have already discussed that physicochemical properties are going to affect the biological activity, but this is not only the steric property. Only steric property is going to not have any role in the biological activity. Along with steric, there must be a presence of electronic, there must be a presence of hydrophobic, and collectively presence of all these factors or physicochemical properties, they have the effect on the biological activity. Alone steric property don't affect, or it is not going to have much more effect on the biological activity. So attempts have been made to quantify the features and the steric features by using, so this is the first attempt, or the attempt made to quantify the steric properties, and the quantification of the steric properties is nothing but the Taft's steric factor, which is measured by comparing the, now this is here we have taken one of the example for comparing the steric factor or the Taft's steric factor and how it is quantified with the biological activity. So this is one example. How we are going to measure? Measured by comparing the rate of hydrolysis of substituted aliphatic ester against a standard ester under acidic condition. Now we all know esters are going to hydrolyze in the presence of acidic media. So here we are comparing the hydrolysis pattern of aliphatic ester with the standard ester when it is undergoing hydrolysis reaction and the ester will be hydrolyzed. Now the hydrolysis of substituted Ks, now the equation we are going to get is Es is equal to, that is Taft's steric factor is equal to log of Kx minus log of K0. So this is a subtraction of the log values of the log Kx minus log K0. Now what is actually a log Kx? The Kx represent the rate of hydrolysis of the substituted ester, that is aliphatic ester, substituted one, and K0 is the rate of hydrolysis of the standard ester. Now the subtraction log values of these two esters is nothing but our Taft's steric factor. So this is a difference between the hydrolysis rate of hydrolysis of substituted ester minus rate of hydrolysis of the standard ester. Now they limited to the substituent which interact stericity with the tetrahedral transition state for the reaction. The Taft's steric factor is going to have its own limitation in which this substituent must be interact sterically with the tetrahedral transition state of the reaction, and they will not be act by the resonance or hydrogen bonding. That means when we are going to quantify the Taft's steric factors, those factors must show the transition state, they must show the interaction sterically, not by the resonance, that is migration of the pi electrons, and not by the hydrogen bonding. They must show the steric interaction between the substituent and the parent compound. Now some of the disadvantages are there for the quantification of the steric factor. So what is the disadvantage? The ES value, that is Taft steric factor, measures the intramolecular steric effect drug interact with the target binding site through intermolecular process. So this is a limitation, that the Taft steric factor will quantify the intramolecular steric effects and not the intermolecular steric effects, but the steric property actually going to involve the process, that is intermolecular process. So this is very important limitation with respect to the quantification of the Taft steric factors. Now this Taft steric factors are calculated by using the molar refractivity. So this Taft steric factors and number of substituents studied by this method are restricted. Now what is the meaning of the word molar refractivity? Molar refractivity is the measure of the volume which is occupied by an atom or a group in the atom. Now just now we have discussed that it is quite difficult to quantify the steric factors, because alone steric factors are not going to have actual role in the biological activity. Along with the steric factors, they may have the presence of electronic factors, shape, size, bulkiness, as well as hydrophobicity constant, hydrophobicity of the molecule, and collectively they will hamper the biological activity. So this molar refractivity is one of the quantifying measure of the steric factor. And what is the meaning of the word molar refractivity? Molar refractivity is nothing but measure of the volume which is occupied by the atom or a group of atom. How much amount of volume they may occupy is nothing but the molar refractivity. And this molar refractivity is obtained by MR is equal to n square minus 1 divided by n square minus 2. This is nothing but the correction factor for the polarization, that is index of the refraction. So the correction factor for the polarization is nothing but n square minus 1 divided by n square minus 2 multiplied by molecular weight of that compound divided by the density. This another part of the equation will define the volume, and the earlier part of the equation will give the correction factor which is involved in the polarization, that is n square plus 1 n square minus 1 divided by n square minus 2. Now n is the number of refractions, m that is molecular weight, and d is the density, that is density of the compound. So what is n? N is actually n is the number index of the refraction. Now the term molecular weight divided by density define a volume. This particular second part of the equation will define the volume, while the first part, that is n square minus 1 divided by n square term, provide a correction factor by defining how easily the substituents can be polarized. That means part of this equation will gives the polarization index, and part of this another equation will gives the volume of the compound. Now measuring the steric factor involves so they are polarized. So this is particularly significant if the substituent has pi electron or lone pair of electron. While measuring the molar refractivity, it is significant that if the substituent have the presence of pi electrons or lone pair of electrons, so this is the significant. Now next steric factor or next point through which we can quantify the steric factor is Verloop steric parameter. Now what is this actually the meaning of the word Verloop steric parameter? This is the measuring value of the steric factor. The measuring the steric factor involves a computer software and the computer program, and the name of that computer program is sterimole. That is, the another steric parameter can be calculated through a software values. They are sterimole. Now this sterimole calculate steric substituents values from the standard bond angle, van der Waals radius, bond length, and possible conformations of the substituent. Now this software based company, this is software based work, that is sterimole, will give the calculate the steric substituent values from the standard bond angle, van der Waals radii, bond length, and possible conformations for the substituent can be measured by the Verloop steric parameters, and this can be used for any substituent. For example, first example is carboxylic acid, and how we can calculate, or how we can measure the carboxylic acid's steric properties. Now next physicochemical property is hansh equation, which is also involved in the physicochemical roles given by any substituent with respect to the biological activity. Now what is actually a hansh analysis? Hansh analysis, if the biological activity is related to one property using single equation, can be easily drawn up for comparing the biological activity with the physicochemical properties. Biological activity of most drug is related to the combination and cluster of physicochemical properties. We have already discussed that any drug's biological activity is the combination of all the physicochemical properties possessed by that drug molecule. Now what is actually a hansh equation? Hansh equation is there which will relate the biological activity to the most commonly used physicochemical properties. So this may be the correction or correlated equation which will correlate the biological activity to the most commonly used physicochemical properties. If the range of hydrophobicity values is limited to the small range, then the equation will be as follow. So what is the equation of the hansh equation? Hansh equation is nothing but log of 1 upon C is equal to K1 log P square plus K2 log P plus K3 sigma plus K4 ES, that is Taft steric factor, plus Kf K5. Now if the P value are spread over a large range, then the equation will be parabolic for the same atoms. Now what is the significance? If the P value are spread over for large range, if the P value, that is log P values, are spread over the large range, then the equation will be parabolic for the some reasons. Now what is the hansh equation? A QSR equation relating various physicochemical properties to the biological activity of series of compounds usually includes log P electronic and steric factors, which is start with the simple equation and elaborate as more structures are synthesized. This equation for wide range of log P are going to give the parabolic type of shape of graph. Now what is actually constant K1 and K5? Now this constant K1 and K5 are determined by computer in order to get the baseline. Now not all the parameters will necessarily significant while we are considering the hansh equation. For example, here we have taken an example of the adrenergic blocking agent. Now this adrenergic blocking agent, that is beta arylamines, this is a parent group which is used as an adrenergic blocking agent, was related to the pi electrons and did not include any steric factor. So they are related to the pi, that means they are involved the resonance, that is shifting of the pi electron, and did not include any steric factors. So this is a general class of beta arylamines, and if we are going to calculate the values, the equation tell us that biological activity increases if the substituent have possible pi values and negative sigma values, positive pi values and negative sigma values. So this equation, that is 1 upon C is equal to significant value pi minus significant value sigma plus significant value 7.89. If the pi values are positive and sigma values are negative, substituent should be hydrophobic and electron donating. If any substitution we are going to substitute, it must be hydrophobic and electron donating. For example, a series of, we are going to consider a 102 phenanthrene aminocarbinols, which is going to be tested for the beta haloarylamines. In that class, these aminocarbinols were tested for their anti-malarial activities. Now, when we are going to compare these 102 phenanthrene aminocarbinols for their anti-malarial activity, it is found that they are going to fit to the following equation, which is provided for the in order to calculate the hansh equation. So what happens if we are going to correlate the phenanthrene derivatives and their biological activity is, suppose we are going to calculate their log P values, then the pi values and the sigma values. Just now we have already discussed that the pi values must be positive in nature and the sigma values must be negative. They will give the better biological activity. So this equation gives the idea about the anti-malarial activity is going to be increased very slightly as the hydrophobicity of the molecule, that is P, increases. If the anti-malarial activity is going to be increases very slightly, when the anti-malarial activity is going to be increased, if the hydrophobicity of the molecule P is increased. So if out of that 102 compounds, if we are going to substitute such a compounds or such a substituent which is going to increase the log P values, that means hydrophobic substituents, if we are going to substitute which will increase the log P value, that means hydrophobicity. So this hydrophobicity of the molecule will give the positive P value, and that positive P value will increase the anti-malarial activity. Now the constant of 0.14 is low and shows that there is slight increasing in the biological activity. Now here we have considered the log P, but the 0.14 value is less, so that means the activity is slightly increased. The log P square term shows that there is an optimum P value for the activity. This P square value of log P, which will give the optimum P value for the anti-malarial activity. This overall activity shows that activity is increases significantly if the hydrophobic substituents are present in the X ring. Suppose we are going to substitute the hydrophobic substituents at the position of X. So this X will increase the hydrophobicity of the molecule. Increased hydrophobicity will increase the log P values, and ultimately they will increase the biological activity, in particularly on the wiring. So substitution X and substitution Y. Suppose we are going to substitute anything which is going to increase the hydrophobicity of the molecule, which will increase the log P values, and ultimately it will increase the anti-malarial activity. Now could be taken to imply that some form of the hydrophobic interactions they are involved at this site. That means electron withdrawing substituents on both rings are beneficial, whether it is X or Y, to show the anti-malarial activities. That this equation allows an easy identification of suitable substituents which are required for the QSAR analysis, and which will includes both relevant properties QSAR as well as physicochemical properties. Then choose a substituent from each quadrant to ensure the orthogonality, and choose substituent with a range of values which will give the each significant properties. So these are some of the references which we have utilized for the formation of this presentation. The majority of the part is taken from the book, that is Graham and Patrick, medicinal chemistry book, that is Graham and Patrick, 3rd edition. Then we have referred Foy's Principles of Medicinal Chemistry book as well as Berger's Medicinal Chemistry series books. Thank you.